Well, so we're going to hand over to Ash Carter now from Advanced Welding. So just want to introduce yourself, Ash, for those that won't have met him.
Hi, can you hear me all right, Wes? Yeah?
Sound, mate. Yeah, loud and clear from considering it's in West Yorkshire, but yeah, it's fine.
Hi, everybody. I'm Ashley Carter. I'm a sales and support representative at Advanced Welding. I'm going to go through a short presentation on the history of electrofusion. I'm going to probably cover a couple of things already said by Dave and Tom, but just stick with me and we'll get through it together. All right. Next slide. So when did electrofusion begin? In the UK, it started around in the 1960s at the Gas Council Engineering Research Station in the northeast of England. The Gas Council, later to be known as British Gas, started to investigate a new wonder material called polyethylene. This had superior properties to the existing metal pipes, and it was much better suited to the recently found North Sea gas. The first PE pipe installation was completed in 1969. The jointing methods for these pipes were socket and saddle fusion for the smaller sizes and butt fusion for the larger ones. These methods worked well, but were complicated as the procedures weren't the same for every make of pipe. This required a high skill level for the installer and made it difficult when joining different makes of pipe between different regions. Next slide. To overcome this, in 1975, electrofusion was proposed as a universal system. At this point, electrofusion wasn't new, and it had been around in Germany and Switzerland since the mid-50s. However, it wasn't used in the UK due to its high fitting costs and the reluctance of UK manufacturers to make the new fittings. To overcome this, British Gas designed their own range of 40-volt fittings called gas coil and asked 5 manufacturers to make them. While the testing was taking place, they designed and made their own electrofusion welding machines. But this never reached the mass market and was only ever designed for proving the system. There's a picture of it just there in your left-hand corner, and you can see it's in a wooden box. What do you reckon? The advanced retro range in the streets for 2021. When the gas coil system was approved, British Gas reached out to a company called Data Acquisition Limited, and they made the DuPont welding machines. This was the first commercially available machine, and it was quickly followed by the Guard Electrofusion unit and the first welding machine from Fusion Equipment, the A30. Next slide. Now, by the early 80s, there were new players in the UK market. Fusion Equipment were becoming more dominant, and MCA Calder had started. The market was expanding as electrofusion was fast becoming the standard way to join smaller sizes of gas and water pipes. Back then, British Gas had a monopoly in the gas market, and they had chosen their manual 40-volt gas coil system, and it worked, so they weren't going to change it. The water market was a little different though. There were multiple companies in the UK, all with different ideas. Some of these companies were keen to try new methods rather than sticking to the manual gas system. Fusion Plastics had patented their Fusomatic fitting system, and some of the water companies started to adopt this. They felt the advantages of the basic manual system. This new technology was exclusive to Fusion Equipment, which was pushing the other manufacturers out of the water market and making them focus more on the gas. And for those not familiar with Fusomatic, there is the resistor molded into the fitting, and the machine reads this and sets the welding time accordingly. This system is sometimes also called resistor pin welding. And it's an automatic system designed to stop possible operator error. While this was happening in the UK, on the continent, companies such as Freatech and George Fisher were also making fittings. But they weren't tied to the British Gas 40-volt system, so they chose a range of voltages which made their manufacture easier. Gaz de France quickly understood this would cause problems, so they patented a new system to use barcodes to identify the voltages. Next slide. By the early 90s, Fusomatic was becoming very popular, and British Gas liked the idea. but they didn't want their market being held to just one supplier. Their solution? Design a brand new system, automatic system, called the British Gas Automatic Recognition System. Easy enough to say, isn't it? With this, the ends of the welding lead rotated so a keyway fit into a slot in the fitting. This selected a specific resistance in the lead end, which then set the welding time. Now, while this worked great in the lab, where technicians knew what to do, in the real world it was obvious the leads could cause bad fittings. This new system was dropped after a couple of years. Another short-lived system was the Durafuse Auto Recognition System. MCA Calder, then owned by Durapipe, designed a system that measured the fitting resistance of the Durapipe couplers and suggested what the fitting might be. This then allowed operators to choose from a short list, speeding up the welding process. Now, this worked for a few years until Durapipe started to redesign the fittings and things became too complicated, so this was also scrapped. With these new systems being tried and failed, the gas and water industries both decided to regulate their markets and introduce standards for the equipment. These now formalise what was expected and how things should work. The gas standard was 40 volt and manual welding. The water standard was 40 volt and manual or fusiomatic welding. At this time though, neither were interested in data logging. Gas and water companies were relying on as-laid drawings sketched on paper after the pipes were in the ground. The European market was a little more progressive, with a new international ISO standard that included barcode welding and full data logging. Now, some of these ideas did creep into the UK, but the technology being used was very basic, and data logging involved printing information on a till roll and stapling it to your job card. Next slide. Now all that changed in 2005 when advanced welding was born. When we started, we had the perfect opportunity to change how people did things. The market needed to evolve, so we listened to our customers. Our first Electrofusion machines were fitted with USB data download ports and alphanumeric keypads, and this revolutionized data logging. And they may seem like simple things by today's standards, but you've got to remember, this was a full 2 years before Apple released the first iPhone, so technology had not yet reached the masses. Interestingly, the UK was still very reluctant to adopt barcode welding. This was probably because many thousands of 40 volt only welding machines were in use at that time and they weren't capable of using these fittings. We understood though at some point this would happen, so we secretly made all of our equipment variable voltage and barcode ready without telling the market. You simply had to plug in the barcode reader and enter a password. Now a few years later, that day arrived. British Gas, or National Grid Transco, as they were then known, started to source uncommon and hard to come by fittings from European manufacturers, and these required barcode welding. Luckily enough for us, we had around 1,500 welding units in the market by then that could easily be adapted to read these barcodes. These new fittings also introduced the first operator restrictions, requiring trained people to carry out the welding. So to control this, we had to introduce a new operator card system, where the equipment is locked and will only ever operate if the ID card is scanned first. These were the first signs of accountability being needed to prove the weld had been done correctly, and this was all 13 years ago. Now that National Grid had opened the door to European suppliers, UK companies had to sharpen their pencils to compete. The introduction of new manufacturing techniques and new materials such as PE100 were physically changing the pipes and fittings being put in the ground. These were the most radical changes since the introduction of electrofusion 30 years before. Pipes were becoming thinner, so they would crush easier, and fittings had shorter cool zones, so misalignment had a bigger effect. The days of using a plank of wood to hold your pipe in place were long gone. Failures dramatically increased, and a bigger emphasis was put on tooling to try and correct this. So we introduced a range of alignment clamps, calibrated saddle clamps, along with new rotary scrapers. This helped, but more was needed, so a bigger emphasis was put on data logging, with network owners now wanting to know exactly who had welded the joints. Accountability was becoming even more important, and the technology inside the welding units was changing to allow this to happen. Next slide. By 2010, we were in the middle of a global financial meltdown. At this time, we thought things couldn't be any worse. Let's wait and see how this coronavirus plays out. We're in day 85 now, UK lockdown. In those tough times, the gas and water companies had to get more bang for their buck, so all costs were scrutinised. Electrofusion failures were more common in the water market, so they started to move away from electrofusion and back onto mechanical joints, so the rework costs were becoming too expensive. This move inspired the owners of Fusion Plastics to create a control point. Their aim to improve the quality of electrofusion and turn the water companies back onto PV pipes. If electrofusion is done correctly, then plastic pipes have many more technical benefits over the metal ones. Control Point started by introducing the red box system, where a camera and telecoms equipment were built into the welding unit. This was the turning point where data became more important than the act of welding. In 2013, the UK gas regulator introduced the RIO framework for deciding how much money the gas companies could charge their customers. Now, I'm sure you all know what RIO stands for, but for my benefit and anyone else who is new to this, it's revenue equals incentives plus innovation plus outputs. And this changed the criteria used to set work, which in turn changed the types of pipes being replaced. This focus on innovation led to a shift in how the market thought, which then allowed us to bring new equipment to a receptive audience. Analysing the all-important weld data, combined with the feedback from the operators, showed us that a large percentage of welds carried out were 63 mm and under. In fact, almost all welds were 180 mm and under. The market no longer needed or wanted a one-size-fits-all 40-volt machine. They needed something that was fit for purpose. This allowed us to introduce a small, lightweight ATS 180 machine, which is designed especially for house connections and works using wireless barcode scanners. At the same time as this, technology was booming, with Apple and Android going head-to-head, pushing the smartphone market out of recognition from a few years earlier. The new tech allowed us to build in new features like GPS satellite location and email directly into the welding units. Improved Bluetooth also allowed mobile phone apps to be used with the welding units, which in turn allowed Control Point to move from the red box hardware to the blue box app. Next slide. So what's next? We think it's going to be big data. The customer assumes nowadays that the welding units will reliably and correctly weld electrofusion fittings. It's now about the data it can provide. The cell phone has suffered a similar fate, where people don't choose the new iPhone 11 because it can make calls. It's about what else it can do. Many countries around the world, including the UK, are implementing tracking and traceability regulations. The asset owner now needs to know who, what, where, when, why, and how the electrofusion machine that can answer this question will be the winner. Cloud storage of data and integration into customer SAP systems is now as important as actually welding the fitting. Now, with all that said, we're not losing sight of the operators. It's all well and good having the smartest welding machine ever, but if it's the size of a small car, the operator won't be happy. So as well as increasing the technology, we are decreasing the size and weight of the hardware. We are focusing on making smaller, more powerful and easy to use machines. In the next couple of years, we see another step change in electrofusion. Advanced welding will be out front, leading the pack. Thanks for listening. if you have any questions, feel free to fire them at me. And